Welcome everyone. Today we are going to talk about one of the most deep physics principles, deeper, deeper than atoms, deeper than uh, atoms, particles, which is waves, specifically electromagnetic spectrum. The electromagnetic spectrum is the range of all possible uh, electromagnetic waves, including the visible light, radio waves, microwaves, X-rays, uh, ultraviolet waves, and gamma rays, including the frequencies, the different frequencies, and all these waves, this range of spectrum, electromagnetic waves, uh, have the same speed of light. The electromagnetic waves are transverse and made up of oscillating magnetic and electric fields, um, explained by the originally derived from an electron. Electron moves under the effect of electric field. That motion of that electron uh, emits two fields, magnetic field and magnetic waves, and electric waves, two fields perpendicular to each other. As the electron goes to perpendicular, even to that two emitted magnetic electromagnetic fields, and these electromagnetic fields or waves have energy of photons, have photons. That photons are considered as energy. Travels travel in vacuum the same speed of light as we mentioned before. The energy of these fields, the electromagnetic fields or the electromagnetic field, transfer the energy from the source to the absorber. The spectral structure is made up of as we said, radio waves, which has radio waves has the lowest frequency, which means long wavelength, and to the right very end of the spectrum, which is the classification, the class of the classification of gamma rays, which has the highest frequency and the lowest and the shortest wavelengths. And the differences between these waves are the frequencies between these rays or these waves are the frequencies and the wavelengths. Energy and the energy as well. Energy is proportionally is directly proportional to the frequency. and inversely proportional to wavelengths. And when we say wavelengths, we mean the distance between two peaks, two peaks of two adjacent or subsequent waves. And furthermore, we have something called refraction or reflection, the behaviors of the waves. The refraction is the deviation of the straight way of a ray of the specific wave, of the specific kind of wave. So it refracts itself when it goes from a medium to another medium. We mean a medium that can allow this specific ray to pass through. It refracts by an angle, and that angle is different from a ray to another ray, or from a wave to another wave, based on the frequency and the wavelength of that ray of waves. Also, the reflection. The reflection is based the reflection angles of that specific ray of a specific kind of waves is different, differ from a wave to another kind of wave based on the ray, on the frequency and the wavelengths. For example, the angles of the reflection or the scattering of that the way of the behavior of scattering or the reflection is based on that wavelengths and frequency. We have microwaves. We say microwaves are comparatively long because they came in the second location from the very left of the classifications of electromagnetic field. They pass through materials like glass, plastic, and reflected by metals. Also, we use them in communication like Wi-Fi, satellites, cooking, the microwave appliance at homes, by that appliance, micro appliance, use these microwaves, and that microwaves have the property of dosing, of vibrating the water molecules and fat molecules, leading them to heat. We have infrared radiation as well, shorter wavelengths. As we go to the right side, we shift to the right side of the spectrum fields, the electromagnetic spectrum field, and this infrared radiation is based between visible and microwave light. This infrared radiation perception is that they get emitted and absorbed by an object, leading that object to heat, and also used in fiber optic communication, remote controls, and thermal imaging. Remember thermal imaging, the cameras, night cameras, translate that infrared radiation to image. We have X-rays used in medical settings. These X-rays have the ability to pass through living tissues and get absorbed by bones, materials like bones. We use them to image the fractures in medical imaging inside the bodies, human bodies, or other bodies, animal bodies. Also used for cancer treatment. The high dose of X-rays targeted to a specific region in body, or the area of cancer, to destroy that cancer cells by damaging the DNA. And the hazard of this X-ray is because they are ionizing. Overexposure or prolonged exposure can harm the DNA, which raise up the risk of getting a cancer. We have also the UV light or visible light used in crime scenes investigation, obtaining the evidences, the seen evidences or unseen evidences. The visible light used for investigators, the forensic investigators, to identify evidence visible to eye, to human eye. And the opposite is with UV light, is used for obtaining the unseen. The evidence can't be seen, like fingerprints, like hair fiber fragments, or bodily fluids that can, like saliva, or saliva, or other liquids. The UV light, furthermore, we're going back to a point that the colors, the visible light was also used for traditional photography, or the tapes, or photography tapes, pictures. Going back to the UV light, the UV light has the length of lower than 400 nanometers, shorter than visible light, which means, as we mentioned, shorter wavelength means more frequency, higher energy, and one of the unique or noticeable or remarkable properties of the UV lights, these rays of UV causes specific materials to fluoresce, to glow, to emit visible light. So we use the invisible light, the UV light, to make some materials, converting that UV light to visible light. This is one of the benefits of the UV light combined with the specific materials. One of the applications of UV light, as we mentioned in forensic fluids, saliva like semen as well, latent fingerprints, fibers, as we mentioned before, visible light or lightening, detecting the seen things by human eye. Light on photography cause there is a hazard, biohazard, called potential biohazard of UV light and infrared light. UV radiation, the overexposure of UV radiation can harm skin cells or eyes, like cornea or retina, harming the cornea or the retina, or even the lens, or causing early aging. And this UV light is one of the most components of sunlight. The infrared radiation, high intensity infrared radiation, can cause thermal burns to skin or to eyes, such as cataracts, because of the high intensity. However, the infrared energy is considered as low energy. This is a brief explanation, is mentioning the main points of the general picture of waves, or specifically electromagnetic fields. And thank you so much for listening.